Alright, so we're now gonna be dealing with the 8th problem, integral problem in Jim Coroneos' list of 100 integrals. And we're dealing with the integral which I've named I again. And I is equal to the integral of x multiplied by sec squared of 2x dx. Okay. So right now, what we're dealing with is, just like the previous question, we're dealing with an algebraic function here in the integrand, and we're also dealing with a trigonometric function in the integrand as well. Two different functions or types of functions. And so that means we're going to have to do integration by parts as well for this question. And so let's we're going to write the acronym LIATE, but I'm not going to bother writing down what they all stand for because I think by now you guys all should know. So we're going to recall LIATE, so log, inverse, algebraic, trigonometric, which I abbreviate to trig, and exponential, which I abbreviate to expo, right? And so I'm going to box this up again, right? So easy reference. And what we're going to do is we're going to look at the integrand, and we have an algebraic and a trig. So let's look down the list. And the first thing we see is algebraic, and that comes before trig. So we're going to let u be x, right? Just like the previous question. So let u be x. So therefore, the derivative of u with respect to x is equal to 1. And if we treat dx as a number, we're going to multiply that to both sides, and we're going to get du equals dx. We're going to let dv be sec squared of 2x, right? And one identity that you have to know is that when you integrate, so for example, I'll do this in another color. So if we're going to integrate, say sec squared of x, right? That's going to be the tangent of x, right? Constant of integration at the end. So that's an identity that you guys all should know. And it's pretty much the same problem, except if we have, say sec squared a of x, where a is, just put it down somewhere, where a is, I guess, some positive integer. Make a note down there. Then in this case, when we integrate that, we're going to get 1 on a tan of x plus c, right? So that's a problem that, I mean, that's an identity that you guys all should know. And yeah, so I might actually like put this on the left hand side, right hand side. So I'm gonna cut, copy, I'm gonna put it over here, somewhere over here. All right. And let's erase this part here. All right. And if you guys aren't aware, this is on your formula sheet now, so you can easily refer to that. No worries. So box this off. Okay. So therefore, when we integrate sec squared 2x, we're gonna get v equals 1 on a tan 2x. And sorry, I was meant to put a over here as well. My bad. So now we can just proceed on to our normal integration by parts, recalling that the formula of integration by parts is u dv, integral of u dv is equal to u times v minus the integral of v du. Okay, that's a formula that we should remember from now. And so we can begin. So let's rewrite the integral question. So I equals the integral of x sec squared 2x dx. And applying the formula, we got uv, and sorry, this should be 2, not a. Oh, I'm getting mixed up. So uv, which is going to be x on 2 multiplied by tan of 2x. And then we're going to minus the integral of v du. So v is half times tan 2x. And du is what we know from here is dx, so we're going to plug that in. And now half is a constant, right? Half is a constant. And what we're going to do is we're going to take that out of the integral, right? So we're going to do this. Yeah. And now in order to evaluate the integral of tan of something, right? So it could be tan theta, tan x, tan y. In this case, it's tan 2x, right? We have to, there's no standard integral result for the integral of tan. We have to convert tan 2x, right? We have to convert tan 2x into sine 2x on cosine of 2x. Right? That's an equivalent statement, and we have to do this because there's no integral result for simply the integral of tan. We have to convert this to, in terms of sine and cos, and then we can do, I don't know, something to do with u substitution or something like that. Okay. So let's do it. So let's keep rewriting. Okay. So that's integrated with respect to x. So what we can do now, right, is we have sine 2x on the top and cos 2x on the bottom. Now, by convention, when we have some sort of integral problem where the integrand is a fraction with, you know, sine on top and cos on the bottom, we can treat it as if it was like a log integral problem. So, you know, things like f prime of x on f of x, because in this case it is true, except for a few things that we need to adjust, right? And this is going to be equal to the natural log of f of x. And in the problem that we're dealing with, we do indeed have an f prime of x on f of x, right? The only problem is that when we treat f of x as cosine of 2x, right, and we're going to integrate that, we're going to get not positive sine 2x, we're actually going to get negative 2 sine 2x. Remember when we differentiate a trigonometric function, and you know it's in the form of, you know, cosine a of x, right? When we differentiate, we're going to differentiate the cosine function, which will turn into negative sine, and then we're also going to differentiate whatever's here, right? Whatever's inside the parentheses, and in this case, the value of a will come out to the front, right, of the trigonometric function. And so when we let u be cosine 2 of x, right, we're actually going to get negative sine 2 of x. So how we're going to adjust the integral so that we can, you know, make it into this form? What we can do is, first of all, we can chuck the minus into the integral, because the minus is simply a constant, minus 1. So we'll convert this back to plus half, and then we'll just chuck the minus in there. Right. And so we're almost there. And now what we really need is we need a 2 in front of the sine 2x. And that's simple enough, right? We can multiply the front of sine 2x by 2, but in order for it to remain as the same integral as in the beginning, we're going to multiply by a half as well. But because half is a constant, we can take the half out to the front of the integral. But there's already a half out in the front of the integral. And so when we take the half out front, we're going to get a quarter outside, because half times half is a quarter. And we're going to get this. So, right? And now we have indeed the integral in the form of f prime of x on f of x, integrating with respect to x. And so we can convert this really easily into a natural log. So this will become x times tan 2 of x over 2 plus a quarter multiplied by the natural log of cosine 2 of x. Right? And of course, this is the end of the integration problem. So we're going to add the constant of integration c. So it's a bit of integration by parts, and also a little bit of trigonometric manipulation. You know, we have to recognize that whenever we integrate a tangent function, we're going to convert that in terms of sine and cosine. And of course, that's going to be sort of like an f prime of x on f of x problem. Because sine and cosines are, derivative, antiderivative, and integral partners at hand as well. So yeah, that's pretty much the end of the question. A little bit, you know, gotta think a bit here and there, but yeah, we managed to solve it in the end.